All right, guys, how's it going today? You're going to want to go ahead and take your notebooks out. We are going to go ahead and start the next section, which is really an extension of what we did at the end of last week, where we tried to multiply a monomial, one term, times a polynomial, more than one term. Today, we're going to start to see some of those things that I think a lot of you guys saw in your map test, where we're multiplying polynomials together, essentially more than one term multiplied by more than one term. So in your notes, we're going to label this section 8.3, okay, multiplying polynomials. So our goal here today, things we're going to take a look at, we're going to introduce what's called the FOIL method. And FOIL just simply is an acronym for us to remember. So just like please excuse my dear Aunt Sally reminded me the order of my operations, FOIL is going to do the same thing where it's just going to remind me what I need to do in order to put these terms together. So we're going to take a look at that in example 2 here. There really isn't an example 1 as far as following along with those in your book. Example 3, probably the most applicable example, the kind of questions we need to be able to answer. And then in example 4, we'll take a look at basically what happens when we have multiple terms like a trinomial or bigger. How do we handle something like that? And once we understand that idea, we could extend it to anything that we would like. All right. Today we're going to leave these two examples go, very similar to what you would have saw Friday in class. Okay. So our two objectives, number one, can I multiply binomials? Remember, binomial means two terms. Okay, so this FOIL method is going to be specific to binomials. And if I get anything bigger than a binomial, so trinomials or more commonly polynomials, we'll have to use the distributive property. We'll talk about how we do that. Okay, so talking about the FOIL method. All right, I don't think there's anybody in this room, if we would take this x right here, if we'd cover it up, okay, everybody in here could distribute the 3 to the x and the 3 to the 2, right? We could all do this, we could all do that, okay? Conversely, we took this away and we covered this one up. Again, I don't think there's anybody in this room that couldn't do the x there and the x there, right? So if we kind of like back this up a little bit, we get a picture, kind of looks something like that, okay? So when you multiply binomials together, you basically have to distribute twice, or what we call like a double distribution, okay? And we could multiply those things together and we could get our answer, okay? Now, the FOIL method is just a way for us to remember that we've got all the pieces taken care of. So if you take a look at this down here, and we'll practice this idea a couple times, I think you'll get the hang of it, okay? FOIL stands for these things. The F stands for first, simply meaning, did you put your first terms together? Okay, the first one in each spot. Okay, the O in FOIL stands for outer, so basically the ones on the outside. Did we put those two together? The I stands for inner. Did we put the inner ones together? And then the L stands for last, the last one in each binomial. Did we put those two together? If you look down the list, we have gotten all 4 items in these binomials multiplied together. So the first ones gave us x squared. The outers gave us a 2x. The inners gave us a 3x. We can put those two together, right? Like terms, total of 5x there. And then the L gave us our last terms, a 6. And so when I put these together using the FOIL method, I end up with a final answer of x squared plus 5x plus 6. Okay, first, outer, inner, last. Okay, so we're going to try this a couple times. I think you'll get the hang of it. Pretty soon, I bet you'll be able to multiply these together without even having to write them down. Okay, so here's the first one we're going to take a look at. S plus 4 times S minus 2 following the FOIL method over here. So we'll just kind of keep those letters off to the side for us to think about. Okay, remember though, F stands for first, so we're putting our first terms together. So S times S is S squared, so got the F taken care of. The O stands for outers, okay, that would be S and a negative 2, so that will be negative 2S, got the outers taken care of. The I stands for inner. That's those two right there. So a 4 and an S, that would be a positive 4S. Got the I's taken care of. Maybe. There we go. And L stands for last. That would be the 4 and the negative 2. So that is negative 8. Got the L's taken care of. In this case, again, those two middles are like terms. So my final answer would be S squared plus 2S minus 8. Okay, so the FOIL method allows me just a way to remember how to multiply these two items together, these two binomials, to produce my answer. Okay, so I'll walk you through one more, and then there's two of them I'd like you to try. Okay, so if we could think FOIL, you can write that down if you want to, or if you want to just keep it off to the side in your brain, thinking about getting all of those pieces together. So first, okay, C times C, in this case, C squared. O, outer, outside ones together. A C and a 4 multiplied together would be 4C. The I would be the inners. That is a 2 and a C. When we multiply, that's 2C. And the L is last. That is a 2 and a 4 multiplied together is an 8. Like terms right there in the middle. C squared plus 6C plus 8. Okay. All right, so let's try these two down here. Go ahead and pause your video at this point, thinking about what am I going to get for answers. Come back, check to see how you did. All right, here we go. So FOIL. First terms, x and 4x. That is 4x squared. O, outer. That is an x and a negative 1, so that is negative 1x. I for the inners, that's those two right there, 3 and 4x, that would be a positive 12x. And L, 3 and negative 1, that is negative 3. So, like terms together there in the middle, I end up with 4x squared plus 11x minus 3. Did you come up with that one? Okay. And number 2, I hope you did not take this 2 on the outside and try to just give it to both the x and the negative 4. Remember, that 2 means that you have 2 x minus 4s. Maybe a little tricky there. Okay? You have 2 of those x minus 4s. So if you did not write that down originally and you maybe did something else, maybe you should pause right now, give it a shot, come back and see if it matches. But here we go. First, x times x squared. Outers, x and a negative 4 multiplied as negative 4x. Inners, negative 4 and x is another negative 4x. And last, negative 4 and negative 4 is a positive 16. Be careful here. These negative 4s do not cancel each other out. And we get x squared minus 8x plus 16. All right. So the FOIL method is a way for me to just simply remember that I've got all of these together. But really, you could also think about it like double distribution. All right. I really am distributing. This x right here has to go, if you follow the arrows, it has to go to the first term, and then it goes to the second term. And conversely, this negative 4 right here has to go to the first term, and then it has to go to the second term. So I still have the same idea as the distributive property. I'm doing it twice, but when we have these binomials, we often will refer to the FOIL method as a way to make sure that we've got all of our pieces. All right. Now, this one, this is the problem that if you were sitting here in front of me today, you'd gripe about, how am I going to do this? You know, what is this going to look like? This is the type of problem we need to be able to do, especially on our air test, okay? So as we read this, a walkway that surrounds a rectangular garden, okay? Picture that, a walkway around a rectangular garden. And I would encourage you to make a drawing of what this looks like. Okay, I've got a drawing right underneath this box over here. Okay, so a walkway around a rectangular garden. The width of the garden is 8 feet, the length is 6 feet. Okay, so this garden is 6 by 8. The width x of the walkway around the garden is the same on every side. Write an expression that represents the total area of the garden and the walkway. All right. So can you think, what is this picture going to look like? I got a rectangular garden. Okay, I know the garden is 6 by 8. There is a path around the garden, almost like a border around the garden, and it's the same on all sides. I don't know what it is. All I'm told is that it's X units, whatever that X happens to be. I'm not here to try to figure that out right now. So don't try to give it a number. Don't try to say, oh, well, it looks like 3 or it looks like a 2. Nope, I don't know what it is. Okay. But my question is to write an expression that represents the total, the garden and the walkway. Okay. So here is my picture. Hopefully you have one. If you don't, hit pause before you see this. All right, give it a shot. What's the worst that happens? Yours is wrong and you have to change it. That's the worst case scenario. Okay. So here's what mine looks like. There's my garden, 6 by 8. Okay. And there's my path around the outside of it. I have no idea how big this space is right here. Okay. All I know is that the dimension is X units. Okay, so don't look at this and don't look at the 6 and try to tell me that you think you know what it is. We don't know. And in fact, to be honest with you, not even sure that I care. Okay, it's not what I'm asked to figure out. Now, if I want to represent the total area, I'm going to need to know the total width from here to here. What is that distance? And I'm also going to need to know the total length. What is that distance? Okay, well, I think I have all the information in order to be able to do this drawn in my picture. Just got to be able to put it together. So from left to right, I know it's 8 feet from left to right. I know it has a path width of X on the left side and a path width of X on the right side. So if I want that total distance, then that simply would be the X, the 8, and the X, or 2X plus 8. Okay. Same is going to be true looking up and down. I know that it's X units wide there. I know that the garden is 6 feet wide there, and another X units wide there. And so from top to bottom, it would be 2X plus 6. Okay. If I know those two things, and I want to represent the total area of a rectangle, length times width, then I should be able to figure out this total area by using FOIL and these two lengths. So remember, FOIL, first, outer, inner, last, first, okay? 2 times 2, or excuse me, 2x times 2x, be a total of 4x squared. If you have not tried this before pausing your video, please pause your video before you try to do this in your notes. Okay. Next, outers, 2x plus 8, or 2x times 8, excuse me, would be 16x. Inners, 6 and 2x, that would be 12x. And last, 6 and 8 multiplied together would be 48. These two terms in the middle are like terms, so my final answer, 4x squared plus 28x plus 48. So if we go back to the original problem, we wanted a walkway, okay, a walkway around a garden, and we knew the garden was 8 feet by 6 feet, and we knew that the path was the same all the way around, okay. Let us to these two dimensions. And if I wanted to find the total area, I multiplied them together using FOIL, and I got a final answer of 4x squared plus 28x plus 48. Okay, so remember, any two items, binomial times another binomial, I can use FOIL to solve that problem. All right, last thing, and then we're done. Okay, here we can't use the FOIL method. Okay, FOIL has four parts: first, outer, inner, last. In this particular case, I'm trying to multiply two items by three items. If it was two items times two items, FOIL would be great. But here, we're going to have to use double distribution. And the only reason that it's called double distribution is because over here we have two terms, meaning we're going to have to distribute twice. Okay? If we had three terms in this first one, then it wouldn't be called double distribution. We'd call it triple distribution. So it doesn't get any more difficult than what we're about to look at, though it may get a little bit longer. Okay, so we'll walk through this one together. I have one more for you to try, and then we're done. All right, so if you got this one down in your notes, we're going to have to make 6 total distributions, okay? But we can only do one at a time. So let's just do one at a time. 5x times 2x squared. That is a total of 10x to the, 10x to the third. We have 1 there. We have 2 over there. That would be 10x to the third. Okay, my next distribution going over there, 5x times 10x, again, that 10 is x has a 1 on it, so this would be 50x to the second. And my last one up here on the top would be the 5x times the minus 6, that is negative 30x. All right. To avoid some crazy confusion, I'm going to draw my next arrows underneath. So from the 3, I'm going to go to the 2x squared. That is a total of 6x squared. Instead of writing it over here, I'm actually going to write it down below because 6x, maybe, 6, nope, can't get my 6 to draw. 6x squared and 50x squared are like terms. And so in a moment, I'm going to put those two together. Next would be the 3 and the 10x. That is a total of a positive 30x. And lastly, the 3 and the minus 6 is a negative 18. So 6 total distributions, right? 6 arrows, 6 new terms. And at this point, I am going to combine those two together. So you can see how that addition and subtraction has come back to play again here in this section. So I have a 10x to the third. My x squareds are a total of 56x squared. In this particular case, the x's drop out, a positive and negative 30x combined to a 0. And lastly, a minus 18. Okay, so my final answer is 10x to the third plus 56x squared minus 18. All right, so last one. Okay, I'm going to ask that you go ahead and write this down, give it a shot. Okay, this is again double distribution because we have 2 terms here at the beginning. I will tell you before you hit pause, be mindful, this 5 is a negative 5. So as you apply that negative 5, it's going to end up changing your signs along the way. All right, so hit pause, give this a shot, all right, and then come back and see if you have the same thing that I have. All right, so here we go. First distribution, 2x and a negative 4x squared is going to be negative 8, maybe. I don't know why this pen doesn't like me anymore. Negative 8x to the third. Okay, then I'm going 2x to a negative 10x. That is negative 20x squared. And 2x and the 3 is a positive 6x. All right, that is half of my work. So here comes the second half. Now be careful because it's that negative 5. So negative 5 and negative 4 would be positive 20x squared. And again, I'm going to write it underneath there because they are the like terms. Next, negative 5 and negative 10, that is positive 50x. And a negative 5 and a positive 3, that is negative 15. Okay? And now I'm going to combine these two together for negative 8x to the third. Again, we see a cancellation there. My next one would be a positive 56x minus 15. Okay? So, like I say, it cannot get any worse than this. It could potentially just get longer if my trinomial here at the end was maybe a polynomial and it had 4 parts. Then instead of distributing 3 times, I distribute 4 times. If I had a trinomial in the front instead of a binomial, then instead of double distributing, I would triple distribute. And I wouldn't have 2 lines of work, but I'd have 3 lines of work. So it's not going to get any harder. It just might get a little bit longer. Okay, please, if anything in here is a little bit of confusion to you, then go back and watch that section again. Okay, but your homework for tonight or today, probably while you're still in class, you're going to do a couple things. Okay, number one, in numbers 12 through 23, those are 3 vertical columns. You're going to pick one. I don't care which one you pick, first column, second column, or third column. In the next section, 25 to 30, okay, there's 6 questions there. You need to pick 2. Doesn't matter. Pick 2 odd ones if you want to. You know the answers are in the back. You could check your work to see if you're on the right track or not. All right. And then number 35 and number 40. So I think, if I remember correctly, that's like 3 questions in the first part, and then 2 questions, and then 2 questions. So you're looking at like a grand total of 7, maybe 8 questions altogether. You can put those in your notebook, or you can have them on a separate sheet of paper. All right. I will see you guys tomorrow. Have a great day. Bye.